Good afternoon, everyone out there today. Thank you so much for joining us for our latest edition of the basic SKYWARN class. We're doing it virtually. This is, I believe, the last basic class that we're doing this year. Correct me if I'm wrong, please, but we do have an advanced class coming up later next week. It basically just kind of expands upon the basic storm spotting concepts. So again, today we'll be running a basic class, take it about 90 or so minutes, so sit back and enjoy it. I'm going to be joined today by Mr. Clint Skelly, one of our very talented and energetic meteorologists at the weather office in Pueblo. He'll be running today's presentation, and then at the end, we can answer any questions you might have. I'll be here secondary supporting Clint. Should any questions you have a burning desire to ask us right then and there, there's basically one way to do it during the presentation itself, because everyone right now is muted. There is a questions box or like a chat feature on your side panel for the webinar itself. In there, you can type your question directly to me. I'll see it and respond relatively promptly. But for the most part, any verbal questions that you might have, again, we'll wait till the very end of the presentation to open up the lines, unmute you one by one after you raise your hand. Again, there's a hand icon on your control panel, and that will unmute your line, ask your question, and we'll go from there. So at this point in time, turn it over to Clint. Clint, take it away, please.
All right. Hey, thank you for that introduction, Greg. So yeah, my name is Clint Skelly. I'm a meteorologist at the National Weather Service in Pueblo. We're going to go over the basic spotter training. And I do have to apologize. For whatever reason, my camera's not working. I know there's one person who wanted the camera going, and I really, really, really do apologize for that. But you know, these expensive MacBooks, they don't like to work when you need them, I guess. So at any rate, we're gonna go ahead and continue on. And yeah, hopefully you guys enjoy it. All right, here we go. Let me get the spotter, this right click, pointer options, and laser pointer. All right, so just a few housekeeping items. Afterwards today, we've changed our policies a little bit, and we're going to be no longer issuing SKYWARN IDs. Instead, we're just going to be asking who you are and where you're at, and then we'll issue a report that way. Use the telephone number on the hail card to report in the calls. It's a 1-800 number. It's the best way to get to us right away. It's toll free, doesn't charge you anything. You can also go to, well, at the end of this class, you need to go to weather.gov / well, I'll just point it out, this right here. We're going to give you a password, and then you can get your certificate and a hail card. So that's the exciting part about that. So here's what we're going to do. We're going to talk about the National Weather Service. We're going to talk about the basic weather concepts, severe storms, how to report it to us, and then the Weather Ready Nation safety. So the National Weather Service has 122 different offices in the United States and the territories. We also have 13 river forecast offices. We use the Tulsa office and the Gulf Coast one for our hydrology. But yeah, so we're located here in Pueblo. We've got our neighboring WFOs, weather forecast offices. This is the Grand Junction office located to our west. They forecast for western Fort Range in the northeastern plains, and then Goodland has a little chunk of the eastern plains in Colorado. Whereas here, we're, of course, Pueblo, Colorado, and we forecast all the way north to the Palmer Divide, down south to the Oklahoma and New Mexico border, and of course, all the way to the eastern plains bordering Kansas. We also forecast the Continental Divide, so up in Lake County, which holds Mount Elbert, which is the largest mountain in the contiguous Rocky Mountains. We also go down to Wolf Creek Pass and the San Luis Valley as well. So we go from the highest point in Colorado down to the lowest point in Colorado, which is just east of Lamar in Prowers County. So who are we? Well, we are meteorologists and other sorts of folk. So we have one meteorologist in charge. We have a new one coming in. Jennifer Stark, our old MIC, went up to the Boulder office as their MIC, whereas we're going to be getting Ariel Cohen from the Miami office, actually. So he's going to come on early August to start here at the Pueblo office. We have Greg Hevener, which you just heard from. He's our WCM. Paul Wolin, our SU. And then we have a bunch of other kind of things. There's more than just meteorologists at the National Weather Service. We have administrative assistants, IT people on staff. We have ETs, the electronic technicians who take care of our radar and our other sorts of hardware. We have a hydrologist, 5 lead forecasters, 7 general forecasters, hydrometeorological. He's actually our OPAL now, which is observation program leader. And then, like I said, the 2 ETs. But here's a look of our little brick office. Looks like a lot of other National Weather Service offices. Small, brick, and pretty cute and quaint, I guess. Here's a picture up here. This is our staff as of last two summers ago, I think. This is Louis Uccellini, the director of the National Weather Service. He came and checked out our office during a severe weather day, actually, which we'll cover in this. So what do? Well, we forecast weather and we do a bunch of other things. We warn, we put out watches, but our main mission is to protect life and property of the United States. So we're always watching. We have 24 hours a day, 7 days a week. We have 2 forecasters minimum on shift. We have 3 main different shifts. So the morning, the day shift, we have the evening shift, and then we have the overnight shift. Overnight shifts are my absolute favorite. If you can catch the sarcasm in that, well, oh well. But we also issue warnings for tornadoes, severe thunderstorms, floods, winter storms, and all the other kind of hazards, including like blowing dust. So, I don't really like this slide too much, to be honest. It's a little pretentious, but things to keep in mind. We're meteorologists. We've gone through quite a bit of training. Myself, I went through 6 years of school. Now I'm on my 4th year at the National Weather Service in Pueblo. We have a lot of different products coming in per radar volume scan. That's about 70 different products that are available as the scan completes. And we look at pretty much every single product to determine if a storm is severe or not. Yeah, and the information in this is really only meant for basic interpretation. This is the basic SKYWARN class. So the basic radar overview and what you're seeing on there. Otherwise, at this last slide or this last bullet point, it's really quite obvious, but you'll not be able to make a warning decision. Well, we're at the National Weather Service, so we do the warnings. But you will be able to interpret it and come up with your own judgment call of what's happening in that storm. So Southern Colorado, we pretty much get everything here besides ocean kind of things. We have the severe weather, and tornadoes, a lot of wildfires depending on the year, a lot of flash floods, river floods, and then of course winter storms. It's, in my opinion, it's like the elite area for forecasting. I grew up in Minnesota. It's pretty flat there. I think weather's just a little bit easier to forecast up there, if you don't mind me saying. But coming here to Colorado, it's a whole different game. So low pressure systems. At a basic overview, we do call them cyclones, and essentially what it is air at the surface. As you can see, this is moving counterclockwise around this low pressure center. In the center, once it hits, all the air goes up. Generally speaking, low pressure systems are associated with rainy and stormy weather. Yeah, and then the opposite, oh, whoops, not quite there yet. Low pressure systems again. So this is what a really intense low pressure system looks like. This was the bomb cyclone last year. This is, again, like an example of an example. It's like the best example you can really get of what a low pressure system looks like on satellite. This is from the GOES 17 water vapor imagery. You can see the air down here is dry air getting sucked into the middle. Got moist air around with convection or thunderstorms developing over Texas and the southern plains, wrapping around, giving us a blizzard over northern El Paso County. Here in Pueblo, we only saw winds, but we saw winds up to 75 miles an hour during this storm. A pretty remarkable storm. It was the strongest storm in the history of low pressure systems in Colorado. So high pressure systems, otherwise known as anticyclones, are air moving clockwise. So this way, air will move from up to down. So generally speaking, it's associated with pretty pleasant weather, clear, sunny, hot. But you know, they're not always associated with it. They can contribute to some sort of severe weather, but we don't really see that too much in Colorado. What we get was you can get a high pressure building over the desert Southwest, and that's a big contributor to our monsoon event, or our monsoon season rather. Okay, troughs and ridges. So troughs generally associated with more poor weather, ridges associated with a little bit more pleasant weather. So this is a 500 millibar map, essentially a map that is depicts the midpoint of our troposphere, or wherever our atmosphere, where our weather occurs. So when you're looking at these maps, you can see these little bulges that go up. That's a ridge, and then these areas that bow down, that's the trough. So just a rough overview. Generally, you're probably going to see some unsettled weather over Iowa, Illinois, Missouri in this area, whereas in this area over here in the Pacific Northwest, it's probably going to be a little bit nicer weather. There's a ridge over it. Also, you can see where the closed low pressure system will be. So that the L that we were just looking at on the previous slide, that would be right here. And you can notice the winds too in this little wind barb. That means air is going this way to the northeast, and on the backside of this low pressure system, it's coming from the north. So it follows that counterclockwise rule that we talked about a little bit earlier. All right, let me drink some water quick, which will happen quite frequently. Okay, so when we're talking about fronts, there are a couple different kinds of fronts, but the first one is the cold front. So this does a really good job depicting what actually happens. So this is the front right here. There's cold, dense air behind the front. The cold, dense air is heavier than warm air. So as it moves towards the warm air is forced up quite sharply. And it can, this kind of lifting mechanism can produce thunderstorms, some severe thunderstorms, but generally a cold front is associated with, I guess, poor weather. Whereas the warm front is the lighter, less dense air pushing into the cold, dense air, and it moves more slowly and it more gradually increases in height. So you can see it moving slowly up. But again, it's also associated with some severe weather. So both of them can cause weather of all kinds of sorts. Generally, if you're out in out in the eastern plains or something like that, a warm front comes through, it'd probably be more of a rain shower kind of event, whereas the cold front will probably be more of a severe event if the environment is right. But again, it can be both. There's also stationary fronts. As the graphic depicts, it's kind of like a little bit of battle between cold air and warm air, kind of just sitting and stalled next to each other, hence the name stationary. But this also means that storms can be produced right in the center point right there. It can produce heavy rain, and it can also lead to flooding. We don't really get that here. I guess you can call the mountains kind of a stationary front, but generally the weather just kind of pushes off from there afterwards. Whereas down in the Gulf of Mexico, you see these flare up quite a bit, and they cause catastrophic flooding over places like Louisiana or Mississippi or some place like that in the Gulf Coast. But we don't really have to worry about that too much here. So fronts, they can be in different sizes. There's the larger scale fronts, and then there's even smaller scale fronts. So a gust front or an outflow boundary, which is seen on the left-hand side here, this is a severe thunderstorm that produced a gust front. So this line right here, that's cooler air behind this line. So warmer, moist air is right here, cooler air is located right here, and this cool air is pushing down down to the southeast. This also helps the thunderstorms continue to develop. So if you see this form on your radar, you probably will see some sort of redevelopment of thunderstorms along this line. Generally, probably right here where the storm's already at, but that's how the storm's able to move to the southeast. Now, dry lines, this is from a satellite. This depicts where the moisture boundary is. So the warmer colors are where the moisture is. These dry colors, or the brown colors, are where the dry air are. So you can see this dry line forms, and eventually thunderstorms develop right along that dry line. Here in Colorado, we frequently do see this dry line form pretty much right over the far eastern counties. So we do get dry line convection during the spring and even in the summer. Also, terrain. Our mountains are kind of a front as well, like I hinted at earlier. But storms form along that mountainous boundary. All right, so I think the most important tool that we do use is the WSR 88D, our weather radar. There are 155 radars out there as compared to the 122 field offices, so there is more than one radar per office. Some places, especially down here in the deep south, they have quite a few different radars. For example, the Peachtree City office uses multiple radars during their Peachtree City's down in Georgia, sorry. But they use pretty much all these radars when they're doing their convective warnings. But they also operate 24/7/365, unless it's not working, of course. Back in, I think it was 2017, our radar went through it's a bull gear replacement, which was a 2-week process. So we didn't have a radar for 2 weeks during monsoon season. It's kind of a stressful period. But this thing, it detects rain and aerosol products, so just particulates or things in the air, including birds, bugs. I don't know if there's a tornado, maybe a cow it'll pick up on. But yeah, it's supposed to not pick up on the ground. There are periods where it does reflect off the ground, so it's not a completely truthful statement. But when the atmosphere's conditions are just right, it'll bounce off of some dense air aloft and hit the ground, and then repeat, essentially. So we do see the ground sometimes. Anyways, so during severe weather, though, we get new scans every 1 to 5 minutes. It is a great technology, but it's still a flawed technology, and this is one of the main reasons why we rely on spotters across southern Colorado, because we don't really know what's occurring at the ground at some points, especially places like the San Luis Valley, the upper Arkansas River Valley, and even the far eastern plains. Once you get towards the Kansas border or like the Oklahoma border, our radar beam is essentially just showing the mid-atmosphere, not near the surface. So we have this thing has an active sensor. It sends out pulses of radiation in our air. It bounces off air particles and it returns it. It's very, very powerful, 750,000 watts, and it's generally a listening device. So it pulses out that piece of radiation, but then it's just listening afterwards to see what comes back. And that kind of looks like this. So here's what this kind of radar is located in this ball, and it spins around in this thing. But essentially what happens is it pulses out, hits this raindrop, hail, grapple, whatever, and then radiation scatters off of it. So you can see it scatters in every which direction. But then whatever makes it back is what our radar hears and what we can see. So if you can imagine, a piece of hail is more reflective than a raindrop that is translucent, and that radiation can go through a little bit. So our radar will pick up on hail. It'll send back a stronger reading than compared to raindrops. We also have a newer technology. It's getting, I guess, a little bit older now, but I think it was in 2008 we started the dual pole radar. So what that does, it transmits a vertical piece of radiation and a horizontal piece of radiation, and that goes into the clouds and it gives us back information. So what we can do with that is pretty cool, actually. The vertical will give us essentially a measurement of how tall the hydrometeors or the rain, hail are, and the vertical will give us how wide it, or sorry, the horizontal will give us how wide it is. So we can use that to figure out what's actually in the storm. So generally speaking, as an example, if you have a big heavy raindrop falling down, it's going to be wider than it is tall, just like this is what I learned back in school. They call it a Big Mac, so it's wider than it is tall, I guess. Whereas hailstones, they're going to be just about the same height and width. That's because it's detecting it as it's tumbling down, so it's got this spherical look as it's falling down through the sky. So we can use this dual pole technology to figure out what kind of hydrometeors in that hailstorm, and it works pretty well. Reflectivity, so generally speaking, the higher up this scale, the more intense the weather is going to occur. So for example, on these outer bands out here, it's more likely just rain. As you're starting to get into these darker reds and purples, you're probably going to start seeing some hail. In general, West Creek right now probably sees some sort of larger hail. We're not quite, just based on this, you can't really determine how big of a hailstone that is. We use other metrics when doing so, but you can probably expect some hail located near West Creek, and the storm's gonna be moving down to the southeast. But yeah, I guess as a rule of thumb, if you have DBZ, reflectivity, DBZ, it's interchangeable, greater than 60. So once you start getting to these values, you're probably gonna get some hail. Now, another product we use is base velocity, and as you can imagine, it tells you what the air is doing in that area. So it looks at hydrometeors, raindrops, hail, and it determines which direction it's moving. So a positive is located right here. These red values are going away from the radar. So our radar is further southeast from right here, where my cursor is, but this red indicates that the air is moving this way to the northwest. These green values, or the negative values, means that they're going towards the radar. So this is kind of a way that we infer how the atmosphere is moving and if rotation is occurring. So you've got a bunch of air moving this way, a bunch of air moving this way. If you infer that it's moving cyclonically like this, this is what we look at to find rotation. So this also shows that the potential of a tornado is there, but we still need to verify it, which is again why we encourage spotters to give us their report. We also got a newer tool. This is the newest tool in our tool belt. It's the GOES 16 and 17 satellites. They're pretty remarkable, but GOES 16, which is now GOES East, which which looks at this area right here. So pretty much the entire CONUS, continental US, but with a emphasis on the East Coast. And then the GOES West, which is GOES 17, looks over the Pacific and more or less the West Coast. But it's a geosynchronous satellite. It orbits at around 22,300 miles above our surface. That is the exact point that is required to create geosynchronous orbit. So that satellite orbits at the same orbital velocity as our Earth does. And so by putting our satellite there, we can get the same exact image every single day. It's pretty remarkable that they shoot a rocket up and put it in the exact spot. It's pretty great, but it's updated. The full disk is updated every 15 minutes, whereas over the US, it's updated every 5 minutes. But you can request a smaller 1 minute section. So during, I guess, severe weather season, we can request these satellite guys to put that smaller 1 minute imagery over our area, so we can, pay hyper attention and see an update every 1 minute. Looks beautiful too. So this is convective initiation. Convective initiation is also a term for just thunderstorm development. So this is a goes east visible satellite image. So before the storms start, one thing to note is that all of these little pop-up clouds are forming. That's what these white spots are clouds. And we call this, the cumulus is becoming congested cumulus. And that just means that the atmosphere is like priming itself for some sort of thunderstorm. The air's trying to go up, but there's something holding it back. This to the northwest up on this section, you can see that the mountains are creating thunderstorms a little bit earlier. And then once these storms form off the mountains, they can move east and go into a prime environment, which is dictated by where this congested cumulus are. And you can see that storm moves over, strengthens up, and let's see if we can see. So this storm formed over the ramparts, went over the Palmer Divide, and then intensified rapidly because the environment was good up there. There are more than one different views that we can see from the GOES 16 or the GOES 17. This is on the left, again, the visible. This is a supercell that occurred back in 2018. And this is the infrared image of that same storm at the same time. We use infrared a lot to, I guess, diagnose how strong the storm is, because the darker the colors in the center right here, see values go down. That means the colder the cloud top is, because infrared, that deals with heat. It'll take a measurement of how cold or how warm the cloud top is. So the colder the cloud top, that means, generally speaking, the higher the cloud is. The higher the cloud is, the more intense the storm is. So let's talk about the thunderstorm ingredients. To get a basic thunderstorm, you need three things. You need the moisture, lift, and instability. Moisture is kind of the fuel to keep the storms rolling. Lift, what you need is something to push the air up a little bit to get the storm started, and then instability, which plays hand in hand with the lift, because once you lift it up into the unstable air, the air will just continue to move vertically. And so that's how you get a basic thunderstorm. But if you want that storm to become severe, you need some sort of vertical wind shear, which we'll talk about the importance of that in a little while. So moisture, we generally get our moisture from the Gulf of Mexico. As I alluded to earlier, well, here are our mountains. Moisture moves from the southeast to the northwest towards southern Colorado. And generally that's where a dry line sets up, because this mid-level air is coming off the mountains, so you get drier air in the upper levels, you get moist air in the lower levels, and then that's just kind of how it works. And I'll talk about parcel theory in a second, but this is a prime setup for severe weather in southern Colorado. So again, Gulf of Mexico moisture, dry air off the mountains. So talk about lifting mechanisms again. This video on the right-hand side is of over the ramparts. You can see thunderstorms are just staying over the mountains. They're not really moving anywhere, just staying directly over the topography. That's because the mountains are a great lifting mechanism. Air wants to move up the mountains, and once it moves up the mountains, it can tap into that instability in the upper atmosphere. See thunderstorms just forming and forming and forming over the mountains. So that's a form of a lifting mechanism, our mountains here. But other ones, as we talked about, the fronts, low pressure systems, dry lines, and thunderstorm outflow boundaries. So this is something that I always kind of struggle to describe well, but this is parcel theory, and this determines how much instability is in our atmosphere. We measure it by using this term called convective available potential energy. Note the potential, it's energy just waiting to be tapped in, or else we call it CAPE. So let's just take a look, follow my cursor here. This is the environmental temperature. So this is the temperature that's outside right now. So at the surface, it's 90 degrees Fahrenheit. Now the air parcel, you have to kind of like just picture this, like there's this blob of air. This is the blob, this blue thing. And once you start lifting this blue thing, it's going to start cooling off. The thing is, this air parcel is more moist or more saturated than the environment around it. So as you force it up, the parcel is going to cool more slowly than what the air's just cooling as you just go up in altitude. So you have 40 degrees Fahrenheit compared to your 32 degrees Fahrenheit. Warm air rises, right? So that thing's going to keep moving up and still going to keep moving up at a slower rate than the environment. 23 compared to 14, minus 12 compared to minus 22, all warmer still. And then eventually you get to this point where you reach equilibrium again. They're the same. The environmental temperature and the air parcel temperature are the same thing. So here at minus 40, this generally occurs at the tropopause, which is the boundary between the troposphere, which is where all of our weather is, the air that we're breathing right now, and then the stratosphere, which is an area directly above our troposphere that's warmer than than the air just directly below it. So at this point right now, this is where the air stops moving up. And this is, if you've seen a severe thunderstorm, we'll show you many different severe thunderstorms, but this is where the anvil forms. So air just moves up, hits this boundary, and then spreads every which way instead of continuing to go further up. But we use CAPE as a proxy of hail size or hail potential size. So you've got CAPE, that's 500 joules per kilogram. That equates to a 35-mile-an-hour updraft speed, which will lead to penny-sized hail. Now go, excuse me, now go extreme, you've got 4,000 CAPE. Now this is an exemplary day, 4,000 CAPE, that's a lot of CAPE. You're gonna have really strong updrafts, 100 miles an hour going directly vertical. That could lead up to softball size hail. Thankfully, we don't see that too often here. I mean, we did back in, what was it, 2018, but it's a rare occurrence. So wind shear is important to separate the updraft and the downdraft, and that will keep the storm rotating and then keep the storm formed. So this is a really good example of what wind shear looks like in the wild. You've got 8 miles an hour wind switching to 14 from the south, 25 from the southeast, or sorry, southwest, 40 miles an hour from the south-southwest, and then almost due west, 70 miles an hour. So that you can kind of see that curvature right there as you go up in the atmosphere. And that'll help support a tilting storm like this. So at the surface, a little bit weaker winds, strong going to the, well, I guess vertically. And again, this is important because you need to separate the updraft from the downdraft. So talk about some thunderstorm types. We've got ordinary thunderstorms. During monsoon season, we see this all the time. You just see pop-up cumulus turning into thunderstorm, dropping a bunch of rain, cold air, maybe lightning, small hail, and then it dissipates and you're just left with the downdraft. It's common over Colorado, like I'd said, and these storms are generally lacking a lot of instability or wind shear. These things can produce heavy rain, localized flooding depending on where it's at. If an ordinary thunderstorm happens to be slightly stronger, if it goes over a burn scar, we might see some flash flooding from that. They can produce small hail, but few of these things become severe. It's more of a lightning threat and a gusty wind threat. Multi-cell thunderstorms are, again, kind of common. You've got, I guess, intensity-wise, they're a little bit stronger than your ordinary thunderstorms, but essentially what's happening is a storm forms, like the cell 1, a gust front forms off of that, and this gust front just continues to move this direction, and it'll keep popping up new cells as time progresses. There are, I guess, different phases. This is the cell 1 is considered the dissipating phase. The cell 2 is the mature stage, and these cells are in their building phases. So generally speaking, you're not going to see that many hazards in this dissipating stage, but this cell 2, which is in its mature stage, you can see some strong winds, hail, etc., located in this area right here. Here's also a depiction of what a multi-cell thunderstorm is. These storms don't look like they quite made it to maturation stage. This one's still building a little bit, but it's weaker. Maybe it was cut off from the warm, moist air. This one appears to continue to build. It's currently the strongest one. You can tell by how high it is. And then right in front of it, there's another one developing. So, and another thing to note is if these things are all moving in the same direction, this could cause flooding just because it's persistent flooding. So this is, you know, it's going to be forming heavy rain. This is going to form rain. This is going to form rain. So if these storms are either moving to, I guess I'll call this east, if it's moving to the east or moving to the west, it's just going to build up a lot of rain over time. That could cause some flash flooding or flooding. Squall lines, they're not too common here in Colorado, but they are pretty things. They form these shelf clouds, and they're generally associated with really strong winds and a potential spin up or a weak tornado forming. So generally speaking, they're linear in appearance on radar. So this is from the Corpus Christi office. This image is, notice how it looks like a big line just moving from the northeast to the northwest to the southeast, right over Corpus right there. They can be very long-lived. There are various types of squall lines that form. Derechos are an exemplary case that are really strong and that can travel to half the continent. Pretty impressive stuff. But the majority of them are smaller ones that form over areas. But the main risks from these things are straight line winds, some hail, and the occasional spin up. Just looking at this right now, we'll get a closer view of it, but you can kind of see this appendage right there. See, and it's moving in this counterclockwise way. Very ominous. This may be a tornado right here. Oh, well, there you go. There is a tornado right there. So these are things that we have to keep an eye out when we're monitoring radar. And there's some of the most difficult things to actually successfully forecast, because not every storm is going to be this close to the radar, which is located underneath my pointer right here. Some of them are going to be further away, so it's going to be hard to see the subtleties that are a small appendage forming off these things. But yeah, this is just something, this little small appendage that could be a small, weak yet damaging tornado. Whereas one of the more common occurrences are the bowing. So you've heard of a bow echo. Well, that's kind of what it looks like. The winds are probably going to be the strongest right ahead of it or directly below it. So supercell thunderstorms, well, I guess they're the rarest occurrence, but yet they're the most powerful and damaging. You need a lot of strong, moderate to strong wind shear. These things can last a while, but what's required by it is they have to have a mesocyclone. So a mesocyclone is a broad rotation in the middle atmosphere. That's the definition of what a supercell is. You need to have this mesocyclone. These are isolated. You can see them, isolated in nature. So as compared to a squall line or a multi-cell thunderstorm, these things are just going to be one big cell. They feed on warm, moist air, but these are some of the more rare types of storms, but they generally cause the most amount of damage or threat to life. They can produce large hail, strong winds, and even tornadoes, as you can see down here. But yeah, this is the thing that is really required. You need an updraft, which is located where you can guess where the tornado is, and then the downdraft, which is where the rain and the hail are. So you can see here's another example. This is where the updraft is. It's rotating. It's going straight vertical, or I guess tilted directly up. This is that anvil that I was talking about. This is the area that's the barrier between the stratosphere and the troposphere. So as that parcel theory example that I mentioned earlier, the -40 and the -40 environmental and parcel temperature, that's where this is at right now. So sometimes these updrafts are so strong that they can even puncture and go through into the stratosphere. And that's where you get this overshooting top. Only the strongest storms are going to have overshooting tops. But again, if you want a supercell, you need to have a mesocyclone, which this right here, it's rotating counterclockwise. Again, tilted rotating updraft. Here's another good example of what it looks like in the wild. These are frequently what mesocyclones look like. You can just infer, I mean, this image isn't, it's not a video, right? So it's a still image, yet you kind of can infer the rotation that you're seeing here. You can see these striations in the structure. This is a beautiful supercell, but you can see it's rotating counterclockwise, and well, sure thing, directly below it, there's kind of an area of rain-free area right below the storm. That's where the updraft is, and then behind it, this dark and ominous looking area, well, that's where the downdraft is. Oh, there you go, the rain-free base. Again, if you're under or near a mesocyclone, really up close, this is what you should be looking for, because this rain-free base area is where the updraft is, and the downdraft is located just off, away from the updraft. In the downdraft, though, that's where you're going to see your really nasty weather, large hail. Yeah, I mean, it's going to vary, but like larger hail is going to be closer to the updraft, smaller than rain as you get further away from it. So if you're out in the field, that's what you see. We'd like to hear about that. You can say, I saw a rain-free base. This is generally where the tornado is going to be. So you can take a look there and determine if there's any sort of funnel or tornado or anything like that, and let us know. This is what it looks like on radar. So the rain-free base is going to be in this area. That's what you're seeing right here. Whereas in this dark and gloomy area, that's probably where this is. So forecasting, well, we have to define what we're forecasting for, though. Severe thunderstorm is defined as hail 1 inch in diameter or larger. We've got damaging winds, so that's greater than or equal to 58 miles an hour, or got the tornado, all of which are severe, and that's the kind of stuff that we want to hear about. As a tiered, excuse me, oh gosh, I just drank water, went down the wrong tube. A terrible feeling. At any rate, we got a tiered approach to our forecasting of severe storms. We collaborate well with the Storm Prediction Center in Norman, Oklahoma, the SPC. So initially, they're going to start out and issue outlooks. So just areas that have all the correct ingredients for severe thunderstorms. As time progresses, we'll issue a watch, hopefully before warning 11 a.m. pretty much on the dot every day. If the ingredients are right, we'll talk with the SPC, determine where we want to put the watch out. It's county based, as you'll see in a second. And then we go to warnings. So this is purely by the National Weather Service offices. So for you guys, the National Weather Service in Pueblo, and it's smaller and it's storm based, so not county based. So this is what the outlook looks like. Here are the counties for the watch, and then much smaller storm-based warnings. A little bit closer look at the SPC outlooks. Here, the large one is the general overview of all severe weather. So if you look at this, what should catch your eye is this little bullseye right here. That's an enhanced. That's where the SPC thinks that it's most likely to occur, severe weather, and the most intense things to occur up in northeastern Colorado, whereas there's a slight risk. So down in southeastern Colorado, we're likely to see some sort of isolated severe thunderstorm, but the brunt of the action will be in northeastern Colorado. You can separate this though. This is the tornado probability. So they're thinking that there's a 10% hatch rate located in northeastern Colorado, whereas this is the wind. They think that pretty much the entire Front Range and Eastern Plains will see some sort of severe, there is a higher probability of seeing severe caliber winds. And then this last one's the hail. And so this day, I think they're more focused on the hail impacts. So there's a 30% chance up in this region that they'd see a severe caliber hail. Putting words to all these definitions of all these words, I mean, general thunderstorms during monsoon season, and even now we pretty much almost see thunderstorms every day, generally not severe, just lightning risks. Going in the future, we'll probably see some marginals here soon, and then slights and potentially an enhanced. But as you go right on this list, the more intense weather they're expecting. So marginal, you might get a severe storm. Slight, you might see a couple severe storms. Enhanced, numerous. Moderate, widespread, and high, widespread, except with long, intense tornadoes. So here in southeastern Colorado, I think I saw just one moderate risk once. I mean, I haven't been here too long, 4 years, but I know we've never had a high risk over Colorado. I think the more common thing is when we think that it's going to be a bad severe day, it's going to be enhanced. Rarely we go to moderate. I think, like I said, I think once in the 4 years that I've been here, we've had a moderate. So what is a watch versus the warning? Well, watch is essentially saying that all of this is possible, all the ingredients are there, but this also means this should be an indicator for everybody to start their preparation stage. So have a plan. If a storm does occur over your area, have the idea of what you're going to do in the back of your mind before the warning comes out. Have it during the watch. They are large, as you saw with the county-based warning. We're good at forecasting, but we're not that good to pinpoint exactly where those severe weathers are going to occur. Now, the warning is meaning that it's happening. It's either been radar indicated or reported by one of you guys that hail greater than an inch, strong winds, tornado, and this means that's danger to people's life and their property. This is the action stage, though. Again, separation here, preparation stage, action stage. This is where you want to take cover. So go away from the windows and go to your safe place. Also, it's a lot smaller in nature than the watches, as you saw with the storm-based warnings. This is it's actually a really good analogy, I think. The cupcake watch versus the cupcake warning. So on this side, well, you've got all your ingredients. You got your egg, sugar. That's a lot of sugar. I don't even know what that is, I guess, but vanilla, baking powder. I don't know. I don't make many cupcakes, I guess. But at any rate, all of these can be analogous towards a severe thunderstorm day. We have, say, the butter is your moisture. Say the flour is your instability. Sugar's your lift, which kind of makes sense. And then all of this right here, that's your wind shear. So put all this together, you're going to start having rotating thunderstorms. And then eventually it turns into this cupcake. Deliciously fierce. So let's talk about watches and warnings again. County-based versus storm-based, as you can see right there. So why did we do that though? Well, way back in the day, but back in the day, a severe thunderstorm warning would look like this. So you couldn't separate it by these zones. So for example, you think that this part of the storm is severe, well, you need a severe thunderstorm warning out for it. But whereas these people right here, they're not under any sort of severe weather. They don't need to be warned. Likewise with these guys, these guys, these guys. It's a clunky way of doing warnings. Whereas nowadays we do storm-based warnings. So this polygon is where we think that the severe weather is going to occur. This polygon and this polygon, instead of it being an entire county. This is great because, you know, we can cancel a warning really easily if there's no severe weather there. And then the way that I like to think about it, when I'm on the warning desk, it's like we have a storm that just went over an area and my grandmother was affected by it. It is now no longer over her, so I want to tell her that she's okay, and that she can leave the basement and resume life as normal. This is probably the main reason why we moved to these storm-based warnings. It's 70% less area covered, and in this case right now, 600,000 people will not be warned by this, which is great. All right, communicating damaging winds and tornado threats in NWS warning. So as with everything weather, it doesn't fit neatly into just boxes. We have thresholds, so EF0, 65, all the way up to an EF5, that is 200 miles an hour, but there's blurs in there. We have straight line winds that can produce up to EF3 damage. So you get these microbursts, macrobursts, derechos, bow echoes. All these things can produce really strong winds, and that could be easily confused as a tornado. So we need to decide what kind of warning we're going to put out, either it be a severe thunderstorm or a tornado. Again, like we kind of mentioned, we look at radar, and that helps us determine if there's going to be a tornado or not. We just look at all of the evidence that we can. It's like we're judges. It's very powerful. But we look at all of the evidence and then determine what we're going to do. So one of the main factors is the environment. So if we do have all of those ingredients to make a cupcake watch and produce a cupcake, well, we're more likely to issue a warning compared to it missing the wind shear. We look at radar data, and as we said before, every volume scan, there's about 70 products that we look at and interrogate, all different levels of the atmosphere. And yeah, that's probably it is the biggest tool that we use when forecasting. But more importantly, we need ground truth. So we take a look at the reports that you guys give us, and then we can better message what our warning says. And you know, just because that weather that occurred over you that you're reporting to us, it's going to go downstream and affect some other people. So if we know what's already in the storm, we can better prepare the people, your neighbors, or the people down in the neighboring town of what's going to occur to them. And you know, if the storm has a good history of producing large hail or tornadoes, we're more prone to issue a severe thunderstorm warning again on that particular storm. It has violent tendencies, and it'll likely continue to have violent tendencies for a little bit for a while longer. All right, so supercell thunderstorms are I guess virtually all the responsible for all the deadly tornadoes in Colorado. Um, yeah, which is true. I mean, land spouts, they are dangerous, but the supercell thunderstorms are the most dangerous. Mainly, you know, and another reason is because they're associated with much more than just tornadoes. They're associated with large hail too. So they're just obviously a more dangerous kind of storm. But we generally know, like I said, with our watches, we're pretty good at determining what's going to happen in a general area. This little graph right here, it shows the climatology of the environment compared to the type of storm that's produced. So for example, if we're going up from one, this is EF scale, EF1 to 2 to 3 to 4 to 5. Generally, what you need is for a weak tornado, decent cape. So this is 1,000 joules per kilogram of cape, and then marginal effective storm relative helicity. That's a proxy of how much wind shear is in the air. So lower wind shear, lower cape, potential for a weak tornado. Whereas if you go up to the EF5s, generally in the Great Plains, this has about 3,200 joules per kilogram of cape with an effective storm relative helicity of around 500. So that's a significant parameter. The environment is prone to large violent tornadoes, and that's when we would issue potentially, or the SPC would issue a high risk day. So again, continuing on, this is the SPC. They've had an enhanced risk out for this day, and there's a 10% chance, a hatch rate of tornadoes. Here is a tornado. They will frequently update this as they see fit, but they're called mesoscale discussions. So if you want to get deep and dirty into the details of what the SPC is thinking, you can look at their mesoscale discussions. And well, this one's 676, so they've released 676 mesoscale discussions, saying why they think the weather is which kind of weather is going to occur. But again, look, it's a pretty broad area. This is all over the Panhandle region. So we're good, but we're not that good, quite that good yet. So as I alluded to earlier, the type of verbs and the type of messaging that we send out it's really dependent on, you know, what we know for sure is happening in these storms. So these severe thunderstorm warnings, we can elevate it with elevated warning, elevated wording. So if I see something on the radar that's begging for me to issue something with 1.5-inch hail as compared to 1-inch hail, that's called elevating the wording. If I see deep rotation connecting from, you know, the lower levels up to the higher levels, but I don't think there's a tornado quite yet, I'm going to issue a severe thunderstorm warning with a tornado possible tag. And likewise with the tornado warnings, we start from radar indicated. And so everything in my training that I've seen means that there probably should be a tornado there when I look at all that data. But then again, I'm still not quite sure because weather is weather. Whereas if we get a spotter report that's saying a spotter report saying that there is a tornado on the ground, we can update those the words to say observed, and that's incredibly important because it shows certainty. And when this goes out to our broadcast partners, they can say there's a tornado on the ground instead of speculating that there probably is a tornado on the ground. Now, if we see or get word of a very large tornado on the ground, we're going to upgrade it to a considerable. That's generally speaking an EF3 or greater. We don't get too many of those, but we'll update our verbiage a little bit to use the word considerable instead. Now, if that considerable tornado is going towards, for example, downtown Colorado Springs, unlikely, sure, but possible, we'll definitely issue a catastrophic tag on that. Generally, it's associated with a tornado emergency, and From my understanding, I don't think we've issued a tornado emergency quite yet at NWS in Pueblo. All right, so why do we need spotters? Well, we need 2 out of these 3 things in order to make us want to issue a tornado warning or severe thunderstorm warning or a warning of any type. So we have the favorable weather conditions and we have the radar indicators. We'll probably issue a warning. But say one of these things aren't really favorable, like say we don't have the favorable weather conditions, but for whatever reason, radar's looking really good. And we're like, okay, well, it's not expected, but it could happen. And then one of you people that you guys give us a report that there's one in Shale, like, oh, that is happening. Okay, so that kind of primes us for the day too. So we know what's happening in that storm. We know that these storms are capable of producing. So we're going to issue a warning, and we're going to be more on our toes to more apt to issue a warning later too. So we need at least 2 of the 3. 3 out of 3 would be great too. But we need you guys because it gives us credibility with the general public and just anybody really. So if you tell us something's occurring, we're going to believe you because you guys are getting trained right now. And we're going to update our wording, and we're going to send out the newest product. And we especially need you guys, well, everywhere, but over places like, say, the far eastern plains, where our radar is only sampling the atmosphere at, like 13,000 feet in the air. There's a lot of air between 13,000 feet and the surface. So tell us what you're seeing. And our radar's great, but it's flawed. So tell us what you're seeing, and we can do a better job issuing products. Another thing is weak tornadoes. They're very difficult just in any situation to see, especially at a distance. The San Luis Valley, you guys get little spin ups all the time. We can't see that. It's only associated with the lower parts of the atmosphere, and we're sampling. 1, we're getting blocked by some of the mountains, and 2, we're sampling the atmosphere like 12,000 feet over that area too. So the point is, you guys are crucial to operations. So again, thanks for being here. So don't report like this guy on the right. That's a bad idea. I mean, I'm comfortable to say that he knows that there's a flash flood or flood going on, but generally speaking, report when you're safe. Once the hailstorm is done producing large hail, go out, try to find the largest storm, or sorry, the largest hailstone, and then give us the report. We don't want you to get bludgeoned or get a concussion or anything like that. That's bad news. And as a rule of thumb, though, pretend like we don't know anything about what's actually occurring. So we may have had a report of inch hail, but don't let that stop you from contacting us. So if we've issued a warning, just don't assume that we know that severe weather is occurring. Just contact us. We'll talk about various ways to report it, but at the end of the day, the person working on the phone desk, well, we like talking to you. So give us a call. All right, now going on to some severe weather statistics. So this is tornado, wind, hail reports. Things to note, there are way more hail reports than there are tornado reports. And there are similar wind reports as there are tornado reports, but these are more common as well. Things to note, we don't get a lot of tornadoes. Northeastern Colorado does. We get a fair amount, not as much. We are notorious for hail though. We thank the mountains for that. So there are differences between tornadoes, non-mesocyclone tornadoes or landspouts, and then gustnadoes. That seemed a little out of place, but whatever. All right, so let's talk about tornado scales by intensity. This is for Southern Colorado, only the NWS Pueblo area, mind you. So we generally only see EF0 tornadoes. This is from 1995 to 2019. A lot of weak tornadoes. EF1 still weak, but dramatically less in frequency as compared to the EF0s. EF2s, even less. EF3, well, we've seen 2 of them, and then we've never seen, at least in modern history, EF4 or an EF5 tornado. Now, the seasonality of these things, well, March, we didn't see any, but they do occur in March. Get a nice low pressure system forming to the south west of us, we could see some severe weather or a tornado. April, we should be ramping up. We haven't seen any yet, I don't think, but I think there's what, one more day? No, today's the last day of April. So this is the last day of April, so we're probably not going to be part of the statistic right here. Now, May, June, those are our money makers for tornado genesis. So we will start seeing some severe weather here soon in May. The severe weather season does generally last through October. This not so much September, October, but tornadoes still can occur. July and August, this is generally when we start seeing our monsoon. Notice the dramatic drop off from June to July. With monsoon season comes a weaker flow in the atmosphere, so it's less likely to form a tornado as you start getting into July and August. Now, divvy it up by hours, though, it's almost like clockwork. It's pretty brilliant to work in Southern Colorado. You know that if you're going to have a bad weather day, it's probably going to occur after 12 p.m. And then last through the afternoon into evening. But as a forecaster, there are a lot of other offices, for example, like the Lake Charles, Louisiana office. Man, they have severe thunderstorms lasting through like the overnight. Just imagine being on an overnight shift trying to focus and stay, attentive to severe weather occurring at like 4 a.m. after working all day. That'd be very difficult. Luckily here in Pueblo, generally speaking, it'll stop by 8, 9, 10 p.m., which is great. But, look at these little outliers, 12 and 1 a.m. These are the gotchas that can occur because the atmosphere is the atmosphere and it's unpredictable. So it can happen. Break it up by distribution. Let's see, primarily these things occur on the far eastern plains, but they can happen anywhere really. Go up to Lake and Chaffee County though. We've never had a report of, at least from 95 to 2019, of a tornado on the ground. Down here, the San Luis Valley, you get a lot of weak storms that are generally not reported. That's why the numbers are so low, but I think they're probably more frequent than we think. So weak tornadoes, 92% of our tornadoes are weak tornadoes, EF0 to EF1. Generally, they last only a few minutes, but they still can be destructive. And these are hard to detect with radar. EF2 to EF3, 5% of our Southern Colorado tornadoes, they're a little bit longer in lifespan and they're definitely stronger with winds. We should be able to see a stronger tornado on our radar, but we still, again, I keep saying this, weather is weather, and it might not occur or it might occur, and that's why we need your help. Generally, they are confirmed by spotters. If you've got a stronger storm, there's a network of storm chasers that are probably around it, or if it's just affecting you in your neck of the woods. Now, we have not seen an EF4 and EF5, and these are the most violent tornadoes. Very scary. This is from Tuscaloosa in April 27th of 2011. A very historic storm during a historic outbreak. These are long track, so they just form and they're just in the perfect environment that they just continue. So they can last up to 1 to 2 hours, just causing havoc and destruction as they propagate with time. Wind speeds are 166 miles an hour or greater. This is an interesting graph though. It shows average number of tornado days per year. So you can immediately see the big bullseye down in Mississippi, 5 tornado days per year. I wouldn't want to live there, but generally these are probably a bit stronger tornadoes. But if you go to the next bullseye, this is up in northeastern Colorado. 4 a year in this area. It's pretty close to, outskirts of Denver. But this is where the Denver convergence zone occurs. So again, these tornadoes are probably weak, but they do occur more frequently than a lot of other places. Down in here on the Eastern Plains, say here in Kiowa County, 3 tornado days per year. So the 2 types of tornadoes, you got the mesocyclone tornadoes and the non-mesocyclone. So non-mesocyclone, we call them landspouts generally. So how does a non-mesocyclone tornado form? Well, it forms beneath generally like this boundary. You got at the surface here, you have wind from one direction, wind in another direction, forming these these cyclonic little circulations at the surface. You get a stronger updraft from maybe some cumulus forming, or maybe a little bit stronger storm, and then it grabs that air from the surface and just sucks it right up and shrinks the diameter of that circulation and forms a land spout. These are the most common type of tornado in Colorado. They are persistent and they are destructive, because you're probably seeing, you know, winds of 100, 110 miles an hour in these things. But yeah, they don't really move too much, just because they're anchored to this one updraft right here. Let's see. All right, it's going. Here's what it looks like. Gary, Colorado.
We're just south of Brush, and we got a tornado basically coming right over our heads here.
As you can see, there's the debris. That's how you know it's a tornado, not just a land spout. And it has to be connected to the cloud base. So you can see cloud base connected to the ground at some point. Pretty remarkable. This is up near DIA. Note again, this is a land spout, so it has to be connected to the cloud base, reach down to the surface. Obviously, debris is obvious. Got this area that the condensation funnel's not so obvious, but you can infer that funnel reforms, connects to the cloud base. So this would be a land spout. Gustnadoes, though, I think this should have some animation on it. I think it's Control L. Yeah, there you go. This is from our own Dr. Carl Bradberg. I call him Carl Bradberg. It's a joke in the office, but this is from Brad Carlberg. He did the talk yesterday, but he took this on the north side of Pueblo. This is a gustnado, because at the surface here, that's where the circulation is, but it does not reach to the cloud base. All right. But, you know, I remember last year there was a gustnado right next to Pueblo West High School, and it caused, you know, a significant amount of damage. So it's not like these things don't cause damage as well. So they're just not defined as a tornado. All right, so we want to hear your reports about rotating wall clouds. I believe this is up in Teller County, I believe. But so rotating wall cloud, lowering of rain-free base. That's not always the case. Sometimes they are rain wrapped, but here in Colorado we have nice dry air. So a lot of our mesocyclones and wall clouds are more rain-free. But you can look for just persistent rotation. You're gonna see this, and I'll show you a video too, but you're gonna see this rotate. You'll see this rotate. We wanna know about that, because that means it's the atmosphere is primed for a tornado. It just hasn't produced quite yet. All right. So this is for training purposes. I'll show you the whole video. So as you can tell, there's a lot of motion there. And if you look at the back of the image, you can start seeing the air move in a different direction. Located, I can't see, here is the inflow. You see that by the beaver tail, they call it. But yeah, that's what a wall cloud attached to a mesocyclone looks like. And we could see the tornado formation. Pretty remarkable footage. All right. Okay. So we want to hear about your funnel clouds too. This is on near Pikes Peak, actually. You see this little tail forming on the topography. So just right there, that just debunks a lot of myths of tornadoes can't form on mountains. Yes, they can. If the environment's right, weather doesn't really care. It'll just do what it does in that area. So in this case, near Cheyenne Mountain or Pikes Peak, whichever one it is. Also, on the other side, right there, that's a funnel. You'll see it spinning. We'd like to know about that. These are funnel lookalikes, though. So it's a little bit of a unfair to just show you a bunch of things like this without, you know, a video associated with it, because these all look like funnels to me. But you know, if you can see it in motion, they're probably just stagnant. Looks like scud. So these are courtesy of James Spann and Bill Murray. Tornadoes, not all of them are completely visible towards the ground. The condensation funnel did not form in the middle section here, but it is causing debris at the ground. So by definition, this would be a tornado because this invisible condensation, or lack thereof condensation funnel, but this invisible funnel is reaching the ground. This is up in Teller County again. That's touching the ground there. And another nice video of what a tornado looks like in the wild. All right. So is this a tornado? I'm not going to do the polling option. I'm not very familiar with the software, but I can tell you that this is not a tornado. It looks like a tornado because there's a condensation from the surface all the way up to the cloud base. But if you were to watch this live, I think actually we can. Yes, it's not rotating. This is coming off of power plant. I believe this is up in Springs. It's a power plant just emitting, and the air is moist enough for that air to condense and look like a cloud. But not a tornado. This one, a little bit more tricky. No, didn't want the pen. There you go. So the air in this one, this looks pretty convincing, like a nice little rope. It looks like a land spout. Got convection directly over it. A thunderstorm, that could be a land spout. But what it actually is, this is a rain shaft. That's just hitting the light correctly that this looks like a tornado or a land spout. But it's not, it's just a rain shaft. So other severe kind of threats that we have, microbursts, straight line winds. So we see a lot of microbursts here in Colorado. Chances are during a nice storm day, you've all probably seen or experienced a microburst of some sort of intensity. But essentially what happens, you've got a thunderstorm that has, ample moisture inside of it. It starts to move that moisture down. Generally it's rain, but the air around it is really dry, and then it evaporates. When it evaporates, it cools. And as we talked about with fronts, the cool air is denser and heavier. So the air accelerates to the surface really quickly. Once it hits the surface, touchdown, there you go. But this area right here is enhanced by the winds moving down at this location, and then the winds spreading on the surface. So this area right here is where your highest winds are going to be, just because you get this, it's like a pressure kind of effect. It's forcing air down and out. Similarly, on this graphic, you can start seeing a more widespread area of the higher winds. Well, due to kind of frictional forces, this air is slowed down in certain areas, and it starts forming these rotors, these little turbulent eddies or rotors. And depending on if it's a wet or dry microburst, you can actually see these things form. It's pretty beautiful. Well, there you go. There's a wet downburst, microburst. So you can see this is that the air evaporating, moving down towards the surface really quickly. This is where it touches down, and you start seeing these little turbulent eddies right here, or rotors. Likewise with this, spreading, and not really a great example of the rotors, but I'm sure the air is quite turbulent in this area right here. Now, dry downburst or microbursts. This one on the right, it's here at or not here, I'm actually at home, but it's at the National Weather Service at Pueblo. Got a nice little microburst, except you can't see the condensation reaching the ground, but you can see the dust form. So less visible, equally dangerous. Now, shelf clouds are associated with squall lines, as we pointed out earlier. You can determine that it is a shelf cloud because, well, it looks like a shelf, but it's also pointing away from the rain. So behind here, it's dark and gloomy, whereas in front of it, there's this nice little shelf where all the air is being sucked into the storm. So you can see that little shelf-like feature. The air going up towards it is moist and warm. The air behind this and this general area is going to be cooler. Now, if you've experienced this before, these shelf clouds will go overhead, and then once it passes, it becomes really windy and significantly cooler. So, wall cloud or a shelf cloud, this top one is a shelf cloud, and this bottom one is a wall cloud. You can see this area, this is how you determine the difference between the two. The shelf is pointing away from the rain, whereas this little appendage is pointing towards the rain. All right, we want your wind reports. Winds greater than 58 miles an hour. Now, there is a lot of confidence in, people's ability, including myself, and I've been proven wrong and wrong again. When it's windy outside, I go outside and be like, oh yeah, it's roughly, I'll call it 45 miles an hour. I'm most likely incredibly wrong. But if you happen to have an anemometer or a wind sensor of some sort, and you have that set up at your place, and you can give us that accurate reading, we would love that reading. Otherwise, we'd like to know the damage caused by the thunderstorms. This is taken from our old WCM, Tom Magnuson, not quite sure where, but severe caliber winds likely occurred in this area to snap off that branch. When describing it, tell us if it's a dead tree limb or if it's a live tree limb, if it was brittle already, the diameter of the tree limbs. We want to know all of that so we can better diagnose what's occurring. We want to know about blowing dust and dust storms. The key is Visibilities less than 1 mile. I kind of like that music associated with that. Very epic sounding. All right. What to report with small hail? Well, we want to know about hail penny size or larger. You know, smaller than that, it's been proven to not cause really any damage. Even the pennies don't really cause damage, but this is where we want to start reporting. It really, separates out things that we see quite frequently. Like we see a lot of P's, BBs, and dimes across southern Colorado. But once we start getting up to this area, this is where it becomes more meaningful, and we'd like to tell people about it. So again, what's required for a severe thunderstorm warning is quarter-sized or larger, so 1-inch hail or larger. And when you call us, don't call them marbles. Marbles they come in all variety of sizes. So I mean, if you're calling in and be like, oh yeah, we've got some marbles, I'll be like, well, are they the shooting kind or the kind that you're trying to get out of the circle? I don't know. Just relay them to us as these common object, pennies up to grapefruits. Hopefully it's not a grapefruit, but these are what we want them to be compared to. This one, hen egg, I don't know about that one. I've seen various amounts of egg sizes in my day. So just say 2-inch hail if you get that. This is a hail card that you're going to be able to access after this. I have one on me right now. I always have one on me just because it's nice to have. This is roughly the size, in person when you print it off. This will be the size of a penny, nickel, and a quarter, and then also 1-inch, 2-inch, and 3-inch in diameter. On the back there, you've got what to report, the number. This is important. Call this number right here. Again, you'll have access to this, but that's our toll-free spotter, dedicated spotter line. It'll also tell you, this hail card, tell us the location and size of the tornado, funnel cloud, wall cloud, wind, hail, or the flooding. So how do you measure this? Well, you would measure it, since we don't have really too much interactivity, from this point to this point, which equates to roughly baseball size hail in this situation. Now, all baseball size hail are not created differently. There's also this kind of baseball size hail. So imagine getting hit by that as compared to being bludgeoned by that. Big difference there. So describe the kind of hailstone that you see as well. If you tell us that, you're like, okay, it classifies as baseball sized hail, but it's just not as deadly or impactful as these guys. All right, this is very large hail. This is I believe it's the world record, for sure the US record, if not the world record for largest hailstone. 8 inches in width. It weighed almost 2 pounds. Came from Vivian, South Dakota, in the year 2010. Now, reports are that there were larger sized hail that fell during the storm, and the storm melted a little bit. Or sorry, this hailstone melted a little bit. So, it was probably a little bit larger than 8 inches, but the official record is at 8 inches. And we do see these kind of storms here in Colorado, as infrequent as they are. I mean, last year they didn't, or 2 years ago, they didn't really seem infrequent, but they are infrequent. This occurred at 2 a.m. You can kind of see that a boundary raced towards the mountain, go up Cheyenne Mountain. It tapped into a lot of instability, formed further south, went over Fountain, went over Fort Carson, and this occurred. So this is courtesy of our old meteorologist in charge, Jennifer Stark. This is her side of her house. This is the size of the hailstone, and those are jam jams. Note, I'm also wearing jam jams because I'm at home. So now this is the Cheyenne Mountain case that occurred August 6th of 2018. This received national notoriety and was on pretty much every news outlet out there. But this thing formed over Teller County. There it is. Formed over Teller County, went southeast, went right over Cheyenne Mountain and eastern Colorado Springs. Most notably, it killed a turkey vulture at Cheyenne Mountain Zoo, concussed a few bears, and there's a lot of people golfing in that golf course around that area. I don't know what it's called, but they were impacted by that hail. These are incredibly dangerous storms, and just imagine getting hit by a softball at 90 miles an hour. That won't feel good. So flood safety, turn around, don't drown. These floods are, they cause the most amount of deaths than any other weather hazard. You know, the flooding could be associated with other things like, you know, say a hurricane on the Gulf Coast, but it's still flooding. So be extra careful when we've issued a flash flood warning or a flood warning. And then there's also this, the half of all flood related drownings occur when a vehicle is driving into floodwaters. So you, at that point, you have that decision. You know, you see flooded waters, flooded streets. You can choose to go over it or you can choose not to. You know, we say, turn around, don't drown, don't do it. And this occurs because of, you know, physics. There's a reason why this thing can float over the ocean. The buoyancy force is greater than the vehicle or the weight of the object. So the moment that water comes, reaches a certain level on your car, this buoyancy force is greater than the vehicle weight. So that's when you're going to start going downstream with that water. So if you see that, here's our little slogan, turn around, don't drown. If you see this, don't do it. You know, just don't. It's not worth it. You can hopefully find another method to get where you need to go. And this is also another thing that can occur. This is in southern Colorado. I'm not quite sure where, but this is courtesy of Tom Magnuson again. A flash flood occurred, wiped out the road completely. Just imagine driving on this road and you saw water flowing over this and you decided at this moment to drive across it and the road washed out. It's a dangerous situation. So when you see that road closed sign, just don't do it. Most flood fatalities occur in vehicles. 12 inches of water can sweep a car off the road, and it's even less than 12 inches as well. Depends on the make and model of your car. So here in southern Colorado, flash flooding is a big issue with burn scars. So we have the multiple burn scars that we're looking over. Got the Spring, the Hayden Pass, and the Junkins. Spring's notably the second largest burn scar in Colorado history. And we also have a brand new one that's not included on this slide, the Decker burn scar near Salida. All of them have their own difficulties of forecasting, but all of them show similar qualities. The soil gets burned, which turns it into hydrophobic. So water phobic scared. The water does not like to be infiltrated, or I guess the soil doesn't infiltrate the water. So it's essentially scared of water. Another thing is all the trees are burned, so there's less canopy there to stop the rain from all falling at once. So you've got scared soil, you've got a lack of trees, or at least the canopy on the trees. It all hits the ground, which is similar to like cement, and it all just rushes down quickly and fiercely. As our hydrologist likes to say, water, you know, just goes downhill really quick. And if all of those other things are associated with it, it's going to go, more water is going to fall more quickly. Other things, regrowth can take many years. The Waldo is starting, we think that it's more or less cured. It's been, since 2013 then that occurred, and it's now getting to the point where we're comfortable around it. We still monitor it, you know, every time a storm goes over it, and we are more prone to issue a flash flood warning on that, but it's proven time and time and again that it can almost be trusted, but not really. I don't trust it still. Other things though, it can contain a lot amount of debris, all these burn scars. Just imagine all these dead burned trees that are eventually going to topple over. Give it a little help with some rain falling down and hitting the burn scar, that tree could topple over as well. So let's talk about lightning. We all, at least this is something I learned back in elementary school, one bolt of lightning is hotter than the sun, 50,000 degrees Fahrenheit, hotter than the sun. That is just it's a crazy thing to think of. It generally generally hits the tallest object, but this is a common theme. Weather doesn't really care where it hits. It's just following the path of least resistance. So if you happen to be in that path of least resistance, you are the object, and 50,000 degrees is going to hit you. And that's, I met a guy at a spotter talk once. I think it was my first one, but he was struck by lightning, and that was incredible to know that somebody, can survive that, let alone survive it. But at any rate, lightning can strike very far away from the storm. So I've heard of, bolts traveling, tens of miles instead of just 10 miles. But as a rule of thumb, it can strike as far as 10 miles away from the storm. All right, so you can see in this, image, this lightning strike is outside of the storm. It's off the base of this mesocyclone, and it's striking far away from the storm. So, as the rule of thumb, if you hear thunder, then you're too close. When thunder roars, go indoors. As you probably know, lightning is deadly. So there are multiple ways. These cows were attempting to get away from the rain, I'm assuming, underneath the canopy of the tree, or they just liked it there. Either way, lightning hit that tree, and then as electricity does, there's a current, and it went across the ground there, and it shocked them all, and it unfortunately killed all those cattle. Now conduction. Now this is a metal fence. The cows were close to the metal fence, touching it. Well, electricity goes through metal. It's a good conductor, and then it shocked them all. So when thunder roars, go indoors. Stop all activity. Seek shelter in a substantial building or hard-topped vehicle, and then wait for 30 minutes after the storm ends to resume your activities. So yeah, if you're out and about, a car is a really good method of being safe in these lightning storms. It's surrounded by metal and then grounded by the rubber tires. So as long as you're not touching metal inside the car, then you should be okay. I mean, granted, your car's going to go all wonky, and all your electronics they're going to kind of fail, probably. Who knows? But it's a safe place for you to be in. So great places: cars, buildings. Even this bus is all right. Where you don't want to be? Well, you don't want to be camping. You don't want to be outdoors. You just don't want to be outdoors. So again, your vehicle offers good protection. So we're getting close to the end. We're going to talk about how to report to us. So again, this is your spotter phone number, 1-800-884-1540. Tell us what you saw, where you saw it, and the time that it was witnessed. How to report it: who you are, where you are, what you saw, when did you see it. There's the hail card doing its function. Beautiful. To beat a dead horse: I am blank. I'm at here. My largest hailstone is a quarter sized, and this was at 5:45 p.m. I am here. I am me. I am here. Walk and don't walk. That's the intersection. I see debris being lofted in the air. No visible condensation funnel. Approximately 2 miles southeast of my location. When? Right now. So just a basis of, what to tell us when you're on the phone with us. Or if you don't want to talk to me, I get it. My wife doesn't even like to talk to me sometimes. Maybe she should just send the email to NWS.Pueblo to get a hold of me. But that's how you can also send reports. And you can also send us your picture that way too. That's a great way to give even more proof of, showing what you're seeing. Just adds more credibility with everything. We also monitor social media all the time. We generally have a person who is dedicated to monitoring that. You've got Twitter at NWS Pueblo. Give us a follow. We'd like to not only inform people, but we like to send neat and informative information about weather happenings around southern Colorado. When you are doing a report, though, you can go to #PubSpotter. We monitor that during severe weather events and during winter weather events. You can send a picture and end your report at the same time via that way. Again, we're constantly monitoring it. Facebook at NWS Pueblo. You can find us. Do the same exact thing as Twitter. You can direct message us in either of these. So yeah, whatever way you feel most comfortable sending your reports. And ham radio. I'm a ham. We've just recently had a bunch of people become hams at the office. Here are our frequencies for Pikes Peak and Pueblo. So 146.970, 146.790. Also, when you're out and about, safety is always first. You don't want to be that guy. You don't want to be that guy. That's just all silly. Common sense stuff, right? Don't do that. You need to follow the traffic rules. Just because there's a severe storm there doesn't mean you need to drive 80 miles an hour on the highway to catch up to the storm. You have to follow the traffic rules. So my gosh, if there's a loop, you go over that loop. Also, southern Colorado, you've got to respect private property. Notice there's some bullets, some BB penetration located in this no trespassing sign. We get it. It's like that's your land, but they don't want people to go in there to grab a hailstone. They want their land left alone. So follow the rules. And the shameless plugs of us trying to get better data. So if you have a weather station that you have connected to the internet, go to there, go to here, weather.gov/pub/join CWOP. This is how we can get better surface data so we can make better forecasts. So right now, let's just say, for example, in Creede, Colorado, which is a high mountain valley a sheer valley located in the Lagaritas. I forget which Mineral County I think it is in. Their weather's really strange there, and our forecasts our starting point doesn't handle it really well. So there are a few places that do have surface observations that we make sure to quality check ourselves. In the middle of winter, they get down to minus 20 at certain times, and our beginning forecast that's produced by our starting point of models has them at 15 degrees or 0 degrees. We need to, it's not either here nor there. It's just a better way to get us information so we can do a better job for you guys. So here's how you can get our forecasts. You go to weather.gov and you'll start seeing this picture on the left-hand side. This shows you the big picture. So clearly there's a winter storm occurring right there. If you want more localized forecast, go ahead and click anywhere in southeastern Colorado. It'll send you to this site right here. And at that point, you can click on this map of where you're located. So if you're in Pueblo, click on Pueblo. I guess this is Colorado Springs. So if you're in Springs, click on Springs. We'll give you a forecast over the next 7 days. So if you want to go into a little bit more detail about the severe weather aspect of things, you can go to spc.noaa.gov and you can see all the things that we're looking at as well. So this, for example, is a day one convective outlook. It looks like there's supposed to be some non-severe thunderstorms over the desert Southwest. And clearly this right there too. But it's a good overview, and you can access mesoscale discussions, as we talked about earlier, and get the full suite of things that we also see. You can also use your mobile device. So as the National Weather Service, one of our goals is to enhance the national economy as well. So we don't like to, I guess, create competing applications to other applications like the weather.com. They have an app. Whereas with us, you have to go to our website. So if you use your phone and go to weather.gov/PUB or wherever you need it, you can get this app-like web browser on your phone. So it'll show you exactly what it is in a mobile-friendly version. What I do is you can add it to your home screen. And, this is what it looks like on an iPhone. On Android, it's very similar. And if you're using a Windows phone, it's probably time to upgrade, but that's okay. You can probably do the same thing. You add it to your home screen, and it'll look like this. So this is a Corpus Christi weather example. It'll look like this, and you can just quickly click that button, and it'll bring you to this. So weather radio, there are plenty of transmitters around the area. This is the surefire way of getting a warning over your phone, over your weather radio. Your phone also has the WIA capabilities, but in the bottom right-hand corner, if you live in any of these areas, this is the frequency that you need. I'm gonna leave this on just for a few seconds so you guys can, take it down. All right, few seconds is up. So the wireless emergency alerts, WIA, this is the latest in trying to get you the information about warnings across the area. It'll only alert if you are within the polygon area. So other things that you can see this used as is the Amber Alerts. Whenever your phone goes off that way, that's WIA. We also have access to that with tornado, flash flood, any sort of thunderstorm warning, a severe thunderstorm warning. We also now use the snow squall warning. That should be included in this as well. So for example, up in Lake County, we issued one not too long ago, and in northern El Paso County, you would have gotten a WIA alert. It's redundant, a WIA notification on your cell phone. So if you want more apps to figure out ways to get whatever you need, we've got the Red Cross and the FEMA app. These both can be found on the App Store and the Google Play Store. So we suggest finding one of these as well. So other forms of staying informed, our broadcast media does an absolutely wonderful job of communicating weather. There's our friend Sam Schreier. We have a close relationship with the NWS to all of our broadcast partners. It's actually quite remarkable. But yeah, stay tuned. They're very smart people, and they'll give you all the information that you need as well. If that's your choice of getting your warning data, your weather data, they're great. But yeah, this is another thing. They do live break-ins. So if you're watching The Bachelorette, I've never seen it, but I hear that's pretty popular. But so if you're watching The Bachelorette and there's severe weather, you're probably gonna go ahead and cut into that broadcast. So can't figure out who's gonna win that Bachelorette thing. So tornado safety. So if you're in a home, what you want to do is get into an interior room or an interior bathroom, or if you have a basement, go into your basement. Those are the safest ways, or less likely to collapse. For example, this is an interior room, likely a bathroom. That's the only thing standing from this, looking like a well-built house. Yeah, this is what it looked like before, I guess. That's a well-built house. The interior room was the only thing standing. I've also heard people put mattresses on top of themselves. If you have the luxury of doing that in enough time, it can't hurt. But more or less, just go into an interior room or a basement. Now, if you're in a vehicle, if the tornado is far away, there's no reason you can't just drive away from it, right? And seek reinforced shelter. That's probably the safest thing. But if the tornado is near you, you can stay in the car seatbelt on and head below the windows because you might get debris shattering the windows. If you're near a very low-lying area, you can get out of the car and lay flat in that low-lying area. The chances of the tornado going directly over you are pretty low, but what the most dangerous part of that is the flying debris around it. So if you're in like a little ditch or something like that, the debris will hopefully just fly right over you. The winds won't be as strong in that ditch as well, so many perks to actually getting into the ditch. But the thing that always just, I don't know, it irritates all the meteorologists is the people going under overpasses. It's essentially a wind tunnel. There's if you want to look into it, it's an application of physics. It's called Bernoulli's equation. And if you force if you force air into a smaller area, it's going to accelerate. So accelerated winds are not good. You're going to get debris flying. You know, it's just, do not go under an overpass. I recall seeing that Superman movie back in, was it Man of Steel? Man, they went directly under an overpass. This is Hollywood. That's how uninformed some people are about things. So just don't go under an overpass. Can't stress that enough. Schools. So we highly encourage you not to go into large open rooms like cafeterias, gymnasiums, and large open classrooms. They're not safe. They have the least amount of structural integrity. So, you know, you see all the metal beams, they're still supported, but all this other stuff fell directly down. I'm not sure if this is one of the cases that people passed away during this, but it has happened before in Oklahoma. It's been on the news and everything. So, you know, you want to get into interior rooms that are well built. And that is exactly the position you want to assume. You know, protect your head and essentially go into the fetal position. But these bathrooms and interior rooms are safer. As you can see, much of it was protected. You want to obviously be on this side, but yeah, it's a safer area in there instead of the cafeterias or larger places. Now, talking about the weather ready nation, essentially what this is just being ready. We want you to be part of our weather ready nation. You know, have a plan for you and your family. You know, encourage your friends, prepare emergency kits, have a weather radio, and, you know, financially review your insurance policies. Hopefully you have all the coverage that you need at your house. So if you are part of a business or an organization, you can become an ambassador. You can promote our weather safety. We can just reach out to us, our WCM, Greg, and he'd be more than happy to get you ready to be a weather ready nation ambassador. Essentially what it is just promoting weather safety in your building. Yeah, so educate your employees on what you want them to do, what they need to do during a severe weather situation. And we'd like to hear some success stories of it. So we're in the last 3 slides, but before the storm, have the plan, know your risks, and practice your plan. Emergency managers do it all the time. They have a plan, they do it. So I'll leave this up for a little while as well. This is the certificate password that you can get on that website location that I said a little bit earlier. And they're both the same, but your certificate password's right there, and your Hail card password's right there as well. SKYWARN 2020. What a strange SKYWARN season though, all virtual. All right, and there you go. This is where you need to go. It's the spotters page, so weather.gov/pub/spotters, and then you'll be able to click on your certificate and Hail card right there. All right, so that is all that we have for this presentation. My name again is Clint Skelly. Thank you so much for taking the time out of your day, especially at 1 p.m. in the afternoon. But if you want to get a hold of me, you can go to clint.skelly@noaa.gov. If you want the office, this is also where you share the photos of storms or just want to get a hold of us in general, NWS.Pueblo@noaa.gov. And there's the big boss man, El Jefe himself, Greg Hevener, the WCM. at NWS Pueblo, at greg.heavener@noaa.gov. Again, here is the number that you call.